Hello everyone, welcome to the second GCSE chemistry lesson. So, here we go. So like I said, the second GCSE chemistry lesson, we are continuing to look at key concepts in chemistry. Last lesson, if you remember, if you watched it, we looked at the atom and what an atom is made up of. We looked a little bit at the periodic table and we looked at ions and ionic bonding. And this lesson, firstly, we're going to do a little bit of revision of ionic bonding, and then we're going to move on to look at covalent bonds. So that's why the learning question for this lesson is, what is a covalent bond? Now, what you will need for this lesson is you'll need a pen and a piece of paper or a notepad. So if you don't have those things, then if you'd like to pause the video now and just go and get them. All right. Also, you'll need somewhere to work, so a little bit of space to work that you can watch this with no distractions if possible, even though I know that might be a little bit difficult at the moment with everybody in the house. Okay, so I'll do it now as a revision question from last lesson, and it's on ionic bonding. Now, if you need to pause the video and just go and have another look at last lesson, or if you want to have a quick look at BBC Bite Size about ionic bonding, then you can do that now. But it's fine if you just want to have a go. That's absolutely fine. All right, we looked at this question at the end of last lesson, and remember I said we'd pick it up at the beginning of this one. So the question was, magnesium has an electronic configuration of 282. Now what that means is, in the first shell of a magnesium atom, in that first electron shell, there are 2 electrons. In the second electron shell, there are 8 electrons. And in the third electron shell, there are 2. That's what makes up that electronic configuration of 282. All right. Then it goes on to say oxygen has an electronic configuration of 2,6, meaning it has 2 electrons in the first shell and 6 electrons in the next shell, in the outer shell. So then the question says, explain, in terms of their electronic configurations, how magnesium and oxygen atoms react together to form the ionic compound magnesium oxide. You can write the formula of that, MgO. And include a description of the structure of solid magnesium oxide. Okay, so if you would like to have a go at that now, then you can pause the video. If you would like a little bit more help, then keep playing the video and I will talk you through it a bit more. So it's up to you. Either pause now and have a go really independently, or wait and I will talk through a little bit more. All right. So here we can see the structures of magnesium and oxygen. And remember, because magnesium is 2H2, its electronic structure, its outer shell has got 2 electrons. Oxygen, because it has 6, it will have 6 electrons in its outer shell because its electronic configuration is 2, 6. All right. Now remember what I said about atoms and how they like to have a full outer shell of electrons. So when they bond together, they are most stable and most happy when they have a full outer shell. So that means that these outer shells of magnesium and oxygen, they would ideally like to have 8 electrons in the outer shell. All right. That is what would make them stable. Now remember, ionic bonding is where electrons are lost or gained. So electrons are transferred from one atom to another when the elements react together. So what will happen here is, because magnesium has got 2 electrons in its outer shell, it will transfer those outer 2 electrons to the oxygen atom so that it can have a full outer shell. And what that will mean in terms of the magnesium and the oxygen ions is that magnesium will have a 2+ charge. So the ion that's left after they've bonded will have a 2+ charge because the atom will have lost 2 electrons. And remember, electrons are negative, so if you lose 2 electrons, then the magnesium will have a positive charge, so that will be 2+. The oxygen will gain 2 electrons so that it can have a full outer shell. So because it's gaining 2 electrons, and electrons are negative, the oxygen atom will have a 2- charge. And this is a picture to remind you of what the structure of the ionic compound magnesium oxide would look like. Do you remember the term that we used to describe how these ions are arranged? So remember, they've got opposite charges, and that's what's holding those bonded atoms together. So the magnesium ions will attract the oxygen ions because they are oppositely charged. So they're packed closely together. And remember, we call that a lattice. Okay, so now time to mark your answer to the question. So remember the question: magnesium has an electronic configuration of 282, oxygen has 2,6. Explain in terms of their electron configuration how magnesium and oxygen atoms react to form the ionic compound magnesium oxide, and include a description of the structure of solid magnesium oxide. So this 6-mark question kind of has 2 parts to it, doesn't it? Because firstly, it says, explain how the atoms join together, talking about the electron transfers or the arrangement of electrons. So that's kind of this first part here. And the second part is asking you to describe the structure of the ionic compound magnesium oxide. So that's why I've kind of written my answer in 2 parts. Now your answer should be written in sentences really, because you do get marks in the exams for writing in what we call prose, which is full sentences, and you get some marks for spelling and grammar and things as well. But I've done bullet points for you to make it easier to mark your answer. So if you read through these bullet points and mark your answer, it's a maximum of 6 marks. All right, so each of these bullet points I will give 1 mark for. So go through and put some ticks in your answer and give yourself a mark out of 6. If you pause the video now and do that, that would be great. Well done. Hopefully seeing lots of ticks. Well done, guys. Okay, so like I said, today we're moving on to look at covalent bonds. So a covalent bond is formed when a pair of electrons is shared between 2 atoms. And usually it's between non-metals. So remember, ionic bonding was where electrons are transferred, so they're lost or gained, whereas a covalent bond is where electrons are shared. So what I would like you to do is pause the video and write down that really important definition of what a covalent bond is. Well done. And here we're going to see an example of a covalent bond. So here we've got a chlorine atom. Now chlorine is in group 7 of the periodic table, and because it's in group 7, it has 7 electrons in its outer shell. You can see that there. Hydrogen just has 1 electron in its outer shell. All right. And remember, all atoms want to have a full outer shell because that's when they are most stable. Okay. Now for chlorine, it will need to get a full outer shell, it will need to have 8 electrons in its outer shell. For hydrogen, because it only has this 1 first shell, it will need to have 2. So hydrogen wants to have 2 electrons to fill up its outer shell. Chlorine wants to have 8 electrons to fill its outer shell. So what happens when these 2 atoms form a covalent bond together is that they share a pair of electrons, and we can see that here. Now this diagram is what we call a dot and cross diagram, and it's a really good way of showing covalent bonding because you can see which electrons belong to which atom. So here, all the dots are belonging to the chlorine atom, and the cross here is belonging to the hydrogen atom. And you can see clearly here that those two atoms are sharing a pair of electrons. So the hydrogen atom has bonded with the chlorine, meaning that they now share a pair of electrons. Okay, and you can see that hydrogen will now be stable because it has this outer shell, because this is first shell, it has 2 electrons in it. And chlorine will be happy too and stable because it now has 8 electrons in its outer shell. And this forms the covalent compound hydrogen chloride. And we can see the formula for hydrogen chloride there is HCl. What I would like you to do is draw out these 2 stages of covalent bonding. So if you can pause the video now and draw those dot and cross diagrams out for me. Okay, well done. So covalent bonding leads to the formation of new molecules, like you can see here. So these 2 atoms have bonded together, hydrogen and chlorine, and they formed a new molecule of hydrogen chloride. Now, in covalent bonding, there are 2 types of molecules that can be formed. The first one are simple molecules. So that's just a set number of atoms that have joined with covalent bonds. And we'll look at those in a moment. The second type of molecule is what we call a giant covalent substance, and that contains many, many atoms that have all joined together by covalent bonds. Okay, so we'll look at those 2 different types now. So firstly, these are some examples of simple molecules that can be formed by covalent bonding. So here we've got the hydrogen chloride that we just looked at. So you've got this pair of shared electrons here. Here we have this molecule. I wonder if anybody knows what this molecule is called. There are 2 hydrogens and 1 oxygen there. So yeah, that is water, that's H2O. And you can see here that there are 2 pairs of shared electrons. So the oxygen is sharing a pair of electrons with 1 hydrogen and a pair of electrons with another hydrogen. And here, this is methane, a molecule of methane. You've got 1 carbon and 4 hydrogens. So its formula is CH4. And each of those hydrogens is sharing a pair of electrons with the carbon. There we go. We've got hydrogen chloride, water, and methane. Here we've got an oxygen molecule. Now oxygen exists in a form that we call diatomic, and that means that 2 oxygen atoms always bond covalently together to make this molecule. That's why oxygen, the formula for oxygen is written O2. Okay, so here are 2 oxygens. They are sharing 2 pairs of electrons there. And this here is 1 carbon and 2 oxygens. I wonder if you can shout out the name of that molecule. Brilliant, yeah, that's carbon dioxide, or C, because there's 1 carbon, O2, because there's 2 oxygens. Well done. So, simple molecular substances generally have a low melting point and a low boiling point, and they are often liquids or gases at room temperature. Okay, so if we go back and look at these simple molecular substances, these simple covalent substances, all of these we can see are liquid or gas at room temperature. So oxygen's a gas. It's a gas in our atmosphere that we need to carry out respiration. Carbon dioxide is a gas. That's the gas that we exhale from our lungs. Hydrogen chloride, water are liquids. And methane is a gas. That's the gas that comes out of the Bunsen burner. So that's the gas that comes out of the gas tap and into the Bunsen burner. So that's right. So simple molecular substances generally have a low melting and low boiling point and are often liquids or gases at room temperature. So that's a really important fact that you need to know. So if you can pause the video and write down that really important fact, that would be great. Well done. So the reason that they have these really low melting and boiling points is because the intermolecular forces, so that's the forces between the molecules, so looking again at the hydrogen chloride molecule that we made a moment ago, the intermolecular forces between those two molecules are really weak, all right? So they're very, very weak. And so therefore it doesn't take a lot of energy to kind of pull them apart. So if you add a bit of heat energy, they start moving apart, okay? So we're talking about these intermolecular forces between the molecules. The bonds between the atoms are quite strong, so it would be quite difficult to pull that hydrogen away from that chlorine, but the intermolecular forces between those two molecules of hydrogen chloride, so here's one hydrogen chloride, here's another, those intermolecular forces are weak. So it doesn't take a lot of energy to overcome them, to make them move further apart. So that's why there's that low melting and low boiling point. Okay, so here are a couple of questions for you. And I will help you this time by talking you through how you would answer them. So there are covalent bonds between the atoms in a molecule of carbon dioxide. Describe what is meant by a covalent bond. Okay? Because this is worth 2 marks, I've written 2 points. So 1 point is a pair of electrons. So each one of them kind of donates one, don't they? A pair of electrons shared between 2 atoms. Okay. The next one is about electronic configurations. So the electronic configuration of oxygen. Now, oxygen has an atomic number of 8. Remember, that's the number of protons in the nucleus, isn't it? So because it has an atomic number of 8, it also has 8 electrons. And there will be 2 electrons in that first shell and 6 in the next shell. So that's why it has an electronic configuration of 2, 6. Give the electronic configuration of carbon, which has an atomic number of 6. So this is a 1 mark question. All I needed to write is the electronic configuration in this note form that we use. So I've written 2 in the first shell because the first shell can only hold 2, and 4 in the next shell to make it up to 6. So remember, there were 2 types of substances that can be formed by covalent bonding. The first one that we looked at with some examples were simple molecular compounds. The second one is about these giant covalent substances. So the first ones that we are going to look at is silica and diamond. So silica has got this huge covalent structure containing silicon atoms and oxygen atoms. So there we go. And you can see by its structure that it's very, very strong. Diamond is made up of just carbon atoms, all covalently bonded together in this rigid network. Okay, and they're all held together by covalent bonds. And because of all those covalent bonds, diamond is very, very hard. So you'll know that because that's what it's used. That's why it's used in jewellery. It's also used in the cutting tips of some tools. So some drills have got diamond in the top of the drill, so it's a really hard tool. Okay. Oh, sorry. Graphite is another giant covalent substance. And what's really interesting about graphite is each carbon atom in graphite bonds with 3 other carbons, and it leaves 1 carbon free. And that means that there are delocalized electrons that are free to move through the structure of graphite. And that's why graphite can conduct electricity. Okay, so graphite can be used for electrodes. Also, another really good use of graphite is that because it's made up of layers that can slide over each other. Oh, yeah, I haven't got a picture here to show you, which is a shame, but graphite's made up in sheets or layers of these carbon atoms, and they can slide over each other. So that's what makes it really good for use in pencils, because when you draw with your pencil, one of those layers slides off onto the paper, and it also makes it a really useful lubricant. Graphene is another form of carbon, and its structure is like just one of those single sheets or single layers of graphite. The other giant covalent structure that you need to know is fullerenes. Now, I've shown you a picture here of a fullerene. It's a molecule made from the element carbon. And this fullerene here is called a nanotube. So it's really, really strong. This tube is very, very strong because it's made up of all these covalent bonds between carbons, and so it can resist a lot of tension. Now, because these giant covalent substances have very, very high melting and boiling points, it means that they are usually solid at room temperature. So we know diamond is a solid, graphite's a solid, silica's a solid. That's because the covalent bonds in them are very, very strong. So they're made up of lots and lots and lots of covalent bonds. Remember, look at the structure here of diamond, lots and lots and lots of covalent bonds. So that means that it takes a lot of energy to break them apart. So that's why diamond has a really high melting and boiling point. Giant covalent substances haven't got an overall charge, so most of them cannot conduct electricity. The only one that can is an exception to that, like I talked about, is graphite. And giant covalent substances are insoluble in water. Okay, that was a lot of information. All right, so you are doing fantastically if you are following this, okay, because that was loads and loads of information. I'm not going to be drilling you with any more information, don't worry. We've just got some practice questions now, which would be brilliant if you could have a go at. So the first question says, explain in terms of its structure why graphite is able to be used as a lubricant. I'm giving you a clue of the structure of graphite here. And which of the following statements about graphite is true? So what we're going to do is start with the first question, and then we'll go through the second question. All right, so can you please answer this first question first? So pause your video and explain in terms of its structure why graphite is able to be used as a lubricant. Excellent, well done. So remember, the layers of graphite can slide over each other, okay? And this here, if you notice, is an explain question. So you need to use some science in there to explain why that is the case. So the layers can slide over each other because the forces between the layers are weak. So remember, these covalent, so if this is a layer of carbon all covalently bonded together, that's pretty strong. So these layers are strong, but the forces between them are weak, so they can slide over each other. Okay, so now have a go at this second question. Which of the following statements about diamond and graphite is true? Okay, which one of those is true? So pause the video and write down your answer for that, please. Brilliant. So we can use a process of elimination here. I know that it's not A. They're both not good conductors of electricity because I can remember that graphite is the only giant covalent compound that can conduct electricity because it's special, because it's got those free electrons. So it's not A. It's not that they can both cut glass. I know that that's just diamond. And it's not that they're both soluble in water, because remember, all giant covalent compounds are insoluble in water. So it must be D. They both have high melting points. Remember, because those many covalent bonds are very strong and take a lot of energy to overcome. Excellent. If you got those right, put a big tick. Well done. Okay, last set of practice questions for you. You're doing brilliantly, okay? So pencils contain graphite. Graphite rubs off of the pencil onto the paper. So diamonds 1 and 2 show how the atoms are arranged in graphite. So So here you can see the layers of graphite here, and if you zoom in to look at a layer of graphite, it's made up of carbon atoms all covalently drawn together. So I would like you to describe the structure of graphite, and if you're feeling really confident, use the diagram to help you explain why graphite can rub off of the pencil onto the paper. Okay, so if you can pause your video now and have a go at answering those questions, please. Brilliant, well done. So the structure of graphite, it's a giant covalent lattice structure. Remember, it's in layers. Each carbon atom is bonded with 3 strong covalent bonds. So we can see here, each of these carbon atoms, 1, 2, 3, 3 strong covalent bonds. That leaves each atom with a spare electron, which together form a delocalized sea of electrons, so those delocalized electrons. And the second question, using the diagram to help you explain why graphite can rub off the pencil onto the paper. That's because the layers have weak bonds between them, so they can slide over each other or separate totally. Okay, well done, guys. Well done. So that's the end for this lesson. Fantastic. So we've done 2 chemistry lessons now. Okay, if there was anything that you didn't understand in this video, then go back. You're welcome to listen to it again. You're welcome to take notes. What you can also do is look up anything that you didn't quite understand me explaining. You could look it up on BBC Bite Size. Okay, well done though, and I will see you soon.